Okay, so third part of problem number 20. From the last video, we substituted y prime and y double prime into our original differential equation. So let me get in my pointer here. So notice 3x, right? This was our y double prime plus 2 times y prime plus 2 times y equals 0. Okay, so all I did was substitute my values of y and its respective derivatives. Now, from this line to this line, the only difference is, you're just multiplying by a factor of x in, right? Remember, this is a power series, so when you multiply in the x, right, this is a bunch of terms that go on to infinity, but when you multiply that x in, right, you get it's really x to the first power, which is, so you have -2, and then you have 1, which is just -1. So that's where I'm getting this guy from. So everything else, right, this is the same thing as this is the same thing as this. The only difference is that -1. So let me maybe get red here. So that was -2, and now it becomes a -1, right? Because I multiplied in that factor of x in there. So that's all I'm doing there. Now, after you multiply the x in, you look at your 3 different series, and remember, you want to work with the same power. So here you have, this is a power series in n plus r minus 1, right? That's a plus right there. N plus r minus 1, and notice I just put it in pink. N plus r minus 1. And then you notice your last series doesn't have that -1. So you want to make this a -1. So we can just rearrange these guys. So what I'm going to do, let me get my pointer here. Okay, so this guy, okay, that's the same, right? I'm just rewriting it. Ignore the green and the orange, that's the next step. But this guy is the same thing as this guy. This power series, exactly the same thing as this power series. Now, I want this guy to look, well, you can see it because I already wrote it down, but I want it to start at, I want this to be, I want it to be n plus r minus 1, so instead of starting at 0, since we can't go backwards, I'm going to start at 1, so if n is 1, and we substitute that 1 here, we get c to the 1 minus 1, which is c naught, which is the same term as if you input n equals 0 for here, you still get c naught. If you plug in 0 for n here, you get n x to the r. And then here, if you put in 1, right, n equals 1 in this guy, you get 1 minus 1, and you still get x to the r. So if you want to write this out on your own, maybe on scratch paper, to convince yourself that these are exactly the same series, they have the same terms, they just look differently, or look different. So that's all I did from here to here. So now you notice my pink, 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 I have the same powers. Okay, so I have the same powers, but now I need the same indices. And I went ahead and, okay, so a lot going on here. So here, this guy, okay, notice it starts at 0, right? This guy starts at 0, right? This guy starts at 1, okay? This, okay, so that's all I have so far. So I have 0, let me maybe put it in a color. So I have 0, n equals 0, n equals 0, and then I have this n equals 1. Well, I want my power series to all start at the same position, so I want them to be n equals 1, all right, because we can't make this a 0. You can't go backwards. So how do I make this into a 1, and how do I make this into a 1? Well, I'm going to write the first, so I wrote this in green here. This power series is the same as this power series. It's just a sum of these two guys. If you let n be 0, okay, in this, and you want to find the first term, well, if you plug in 0 for n, so for example, right, you just put in, whoops, right, okay, you get 0 plus r, for example. And then if n is 0, okay, r minus 1, c 0, and then you get x to the r minus 1. Okay, and then this is 0 plus r, which is just r, so that's fine. So this, if you, again, this is the first term with my 3, so that's what I have exactly right here. Now that's just the first term of the power series. We need, the rest. So then I'm just going to start, instead of writing obviously the infinite sum, we're going to start at n equals 1. And then when n is equal to 1, right, we're going to have this these expressions here. So again, this, if you want to write this guy out on scratch paper and you want to write all of this out and start, plugging in the indices, you'll see that the terms are exactly the same. And then similarly with the second power series, right, the orange, right, so I have 0, but I want a 1. I want to start at 1. Well, okay, so I have this guy, and again, I did the same thing that I did here. I let n be 0, and when n is 0, I get the first term plus the rest of it, which, again, you really just copy the same thing, but you start at n equals 1. So again, orange and orange are the same. And then this guy's already 1, so, well, it's 1 here. It starts at 1, the index, so we don't need to change anything. Let's see. Okay, so I write really big, so I have one whole line here in 2. So I have this guy plus this guy plus this guy equals 0. And what I'm doing here, I'm just combining arranging my terms with my like terms, I guess you could say. So the first term, right, is this guy. The first term is this guy where n equals 0. So I basically put these guys together. So maybe I'll put this in. Okay, so here is my green, and then let me get an orange here. Okay, that's orange. And there is my orange part, right? I'm talking about this guy, that specific one, and this actually specific one. Okay, so I just put those two guys together, and again, I just carried on, right? I have this guy, and this guy. And, we've done a lot of this in section 3.1. And let me make this a little smaller so you can see, right? We factored out that x to the n plus r minus 1 because they all have an x to the n plus r minus 1, x to the n plus r minus 1. So, right, x to the n, there we go, right? That is this guy here, right? You're just combining like terms. And then we're left with this guy, and I ran out of room, so that's equals 0. And so again, a lot going on, and if you ever get confused, you can just write out the power series, and you'll see that you'll see the actual terms, because there's many terms here. And then we're doing the same thing that we, again, in 3.1. So here I have two pieces. I have, okay, so I have for n equals 0, right? So if it starts at 0, we have this guy, and then of course when n equals 1. So for n equals 0, I'm just looking at this part. And notice that there's a factor of, right, x to the r minus 1 is in common, so I just factored it out. And the rest is just algebra, right? Well, here we're equating the coefficients, right? Distributive property, we know it's quadratic. This guy, right, that ends up just being negative r, which I actually wrote here. And then we get that r is 0 or r is 1/3. But remember here that we're multiplying this guy by c naught, and that's supposed to give me 0. So we know c naught is 0 when r is not 0. So I'm going to go ahead and continue this in the next video, just because it's almost 10 minutes, and hopefully we'll be done with the problem.